will be saved and it will be sent out to you guys so that if you can't do it with me right now, if you're just here watching and saying hi to your classmates,
Thank you.
I'm so happy that you're still here, you'll be able to go back and do it later, okay? So I'm going to put my water and I'm going to have it start to boil on our stove. And then I'm going to get my cabbage ready. So this is a purple cabbage. This is a huge purple cabbage. Sorry, the computer screen is just a little too tall for this screen. You can only see part of my face, but now you can't see me chopping the cabbage, but that's okay. So this is a purple cabbage. I was testing this a few days ago. That's why it's cut. I was looking into other things that you could use to make pH indicator solution. Purple cabbage is the best, and we're going to talk about why that is in just a minute. But there are a couple of other things that you could use. Like if you've ever had red onion, you could use the skins from red onion. Grapes might also work, or like blackberries or blueberries. Really any vegetable or fruit that has a purple color might work for this. Purple cabbage works the best.
Purple.
So we don't need a whole lot. I think I said in the document about 2 cups of it chopped. So and it doesn't have to be chopped super small. So I'm just going to kind of cut off a sliver and get mine chopped up here. If you're using a knife at home, be safe. Here's my little container. And I'm going to put it in there. Yeah, that's about 2 cups. If it's not exact, if you have a little bit more, a little bit less, it's still going to work. We just want to get enough cabbage in here to draw out the liquid. So I'm going to check on my water. Okay, it is not boiling yet.
Yeah.
So while we're waiting for it to boil, I'm going to put my head back up here. While we're waiting for our water to boil, let's talk a little bit about why we're using this cabbage and why cabbage works for our experiment that we're doing today. So we have a word, when something has a color to it, we say that it has a pigment. Cabbage and grapes and red onions and anything that has this purple pigment in it, it's called flavin. That's the chemical in it that's giving it that red color. So flavin is naturally a neutral compound, and it's purple colored. So when we boil our cabbage in just a minute here, we're going to be extracting the purple liquid out of this cabbage, and you'll get to see what it looks like when we're done boiling. And your cabbage will kind of be like a gray, gross, like almost green, slimy color. That's because when we boil it, all the flavin, that purple pigment, is coming out of the cabbage. So flavin, like I said, it's neutral, and it will turn a different color if it's in the presence of something that is acidic or something that is basic. If it's exposed to something acidic, it's going to turn to a red. And if it's exposed to something basic, it's going to be like a greenish yellow, which you'll see as we go through this. I'm going to talk a little bit more about the chemistry of acids and bases as we get our cabbage to boil. And I'm going to show you guys what I'm testing once I put our cabbage in our boiling water. If you are making this along with me, you can grab some things that you see around your kitchen to test once we throw our cabbage in. There's going to be some basic stuff. I'll give you some suggestions. But yeah, you have a lot of just household items already that will be really cool to test. And if you don't have the same ones that I do, that's awesome. That's fine. You can test whatever you want and we can compare our results. Okay, let me check on my water. Check on yours if you're making it. Okay, mine is just about there. So I'm gonna take you guys with me. So my water is not quite boiling yet. Oh, you can't really see. Now I'm dropping cabbage. It's at a slight simmer, but to save time, I'm going to put in, I'm just going to dump my cabbage in like this. And I'm going to let it go.
Where do I smell celery?
Why do you smell celery? I don't know. Sorry, that was probably not a question directed towards me, but I'm going to answer it. Okay. So I'm not going to turn my heat off yet. Once it starts to actually boil, I'm going to turn the heat off. And then it just needs to sit in the hot water like it's sitting in a hot bathtub. I just want to get it going here. Okay. So we've been covering acids and bases in our prep work. We've been doing, you guys got to see, if you finished that first video, you got to see me do that, that reaction with the baking soda and vinegar. And I was using, like I said, these pH strips to test that. So, but what's actually going on with acids and bases and what makes them different is the concentration of what we're calling hydrogen ions. And that was mentioned in our PowerPoint that was in our prep work this week too. So we call something an ion. That's going to be a molecule of an element off the periodic table. We call it an ion if it has a positive or negative charge. So if you can remember way back to the beginning of our chemistry unit, we have protons and we have neutrons and we have electrons. Can someone shout out what is the charge that an electron has?
A positive.
An electron.
Negative.
Yeah, electrons are negative. Yeah. So remember,
That was that. My mom said the wrong thing. My mom said positive.
Don't tell me.
It's okay. I know it's been a while since we've been out, but remember the P's go together. So protons are positive, neutrons are neutral, and electrons are negative. So in an acid, that's going to be a solution that has a lot of hydrogen ions, meaning it's going to have a lot of hydrogen molecules that are missing an electron. Because if they are missing an electron, that means that they're going to have a positive charge because they're missing that electron that makes them a neutral atom. So an acidic solution, so a liquid that is acidic like vinegar or any type of acid, has a bunch of hydrogen ions in it. So it has a bunch of hydrogen molecules that are all missing an electron. A base has what's called a hydroxide ion. And hydroxide is an oxygen and a hydrogen compound that has a negative charge, meaning it has an extra electron. So that's kind of what's going on with the molecules inside our acid and our base. So I'm going to check my liquid. Okay. Mine is boiling. So if yours is boiling, turn off the heat. Leave your pot on the stove, but just turn off your stove.
Hey guys, if you're not asking a question, why don't you mute your mic so we can make sure we can all hear Miss White, okay?
Thank you, Miss Jones. Yeah, so some of us that might have joined in might have missed that announcement. Yeah, if you're not answering a question, mute your mic. If you want to just type in your question, I am periodically checking the little chat box over here on the corner. So you can also type in a question if you have one. So what I just did, for those of you that are making this along with me, I turned off my stove. Can't really see it. That's okay. And I put 10 minutes on the timer on my microwave. So just like you're making tea, like you set the tea bag in the hot water and let it steep for a little bit. We're now going to let our purple cabbage just sit in the hot water, and that's going to draw out all of that purple pigment. And since the stove is off, it's also going to give us a little bit of time to let it cool. So while we're waiting for that, I'm going to show you guys the things that I'm testing. And if you want to start kind of looking around in your kitchen for some things for you to test, then this would be a great time to do that. So I'm going to test some baking soda right here. You guys know that I love LaCroix, my seltzer water. So I'm going to test to see if my seltzer water is acidic or basic. I've got some lemon juice here as well. I'm going to test my lemon juice. What are my other things? Oh, I'm going to talk about this one in a minute. A great place, of course, with parent permission, a great place to look for things to test. I know a lot of people have like that under the sink cabinet with all the cleaning supplies in it. A lot of these cleaning supplies could be interesting to test. So get some parent permission before you start just grabbing cleaning supplies out. But in here, I'm going to grab out, oh, I can't get it up. I'm going to grab out some of this oven cleaner. Oven cleaner is a really powerful cleaning agent. It's really good at breaking through grease. So I want to know if that's going to be acidic or basic and how acidic or basic. Okay, let me get up off the floor here. Okay. What are some other things I'm going to test? I got that, this one. I'll talk about this one now. So this is called lime. So lime, we probably think of lime, you think of the fruit, right? Or like lime juice. Does anyone also think of a substance that has the word lime in it that we have heard about before? Besides lime juice or the fruit?
Limestone?
Limestone, exactly. Yep. So limestone is a rock. It's a type of sedimentary rock that you can find, but lime is a compound that can be extracted from sedimentary rocks. And it's basically just like a powdered compound here. Ooh, this is not powdered up limestone, but there is lime in limestone. So this is a mineral. Excuse me, I was saying compound. This is a mineral called lime, and it's found in limestone. And it's used, I'm not going to tell you exactly what it's used for because that's going to give away if this is an acid or a base. So I will tell you what it's used for after we test it. It should not matter if the club soda is kind of flat. I mean, maybe it will, but that's the fun of science. Sorry, that was a question in the chat box. We can test it and see what happens. And see, yeah, how that works. I actually, when I was testing this stuff earlier this week, I tested a different brand of this sparkling water. So we might get a different result than what I got the first time. Some other things. Oh, that's a great question, Miss Jones. So Miss Jones wants to know, will different flavor LaCroix have different results? That would be really interesting if we tested maybe, this one is a lime LaCroix. Unfortunately, I don't have any other flavors here. We don't have anything, but if anyone else has LaCroix and you're testing it, we can compare our results afterwards, or if you're doing this later and you have a different flavor seltzer water. But that's a great question, Miss Jones. I'm also going to grab out of my refrigerator some buttermilk. So this should sound familiar for those of you that have gotten to our discussion for this week. We were talking about biscuits. It was asking you to find a recipe that uses buttermilk. So I want to show you guys exactly what buttermilk looks like when we're testing it. Ashley, can we do it with non-liquids like cheese? It will work best with a liquid. You could maybe try to melt the cheese and see what happens, but no guarantees on if that will work or not. When we're testing acids and bases, it's typically best to do it with something that either is a liquid or will dissolve in a liquid. So like my baking soda right here isn't a liquid and neither is the lime, but they will both dissolve in the liquid. So Ashley, if you want to take that upon yourself though and melt some of that cheese, let me know if it works. It might not. Yeah, you can definitely do salt. Salt will dissolve in a liquid as well. Okay, so let me see. Some other things, like if you want to test something that's not in your kitchen, like shampoo or soap, or like your body wash, those would all be great. Kata, you're just going to use a little bit of each of the items, like a teaspoon to less than a teaspoon. It doesn't take a lot to see the change take place. So if it's something that you don't want to use a lot of, if it's something you don't want to use any of, then don't test it. But we're only going to use a splash of each of these different things that we're going to test. Like I said, about maybe half a teaspoon even, just a tiny bit. Okay, let me see. Ooh, dropping things. You didn't see me drop things. Let me check my time. I've still got 3 minutes on my cabbage. Any other questions? Oh, so it depends on the substance. Ashley asked if you did use too much on accident, would that be bad? Sometimes it depends on the substance. If it is something that has a color to it, like if you're testing like a fruit juice that is like bright red, if you use too much of it, then the red color won't give you an accurate result. Or like if you're using something that's like a green color, if you use too much of it, then that color will block the pH indicator. So it'll still work if you use too much. It just sometimes will be harder to tell what color the cabbage juice is going to turn. In our last couple minutes here, I'm gonna get my little testing station set up. I said in the document today, a strainer isn't necessary, but it will be helpful for you to get some of your juice out without getting cabbage chunks in it. So I'm going to use one like this, but if you have a colander, like if you have something like this, one of these containers, anything that you can pour a liquid through and it will catch the things. So Isabella, it reacts really quickly. So we'll be able to see this color change happen pretty quickly in our liquids. We'll just need to give it a little stir and we'll see that change. And like I said, if you're going to be testing a couple of things, you're just going to want like some drinking glasses out so that you can put a little bit of your mixture in them. So before we left, one of the things that I grabbed from the school was a bunch of, throwing things, a bunch of these beakers. So I'm going to be using these little beakers here, and I'll tilt my screen down, don't worry, once we start testing. But if you have like juice glasses or bowls even, like any sort of bowl, you just need a different container for every liquid that you want to test.
Miss White, Ashley asked a question.
Oh, yes. Does it matter how dark? Are you thinking about the color of the liquid, Ashley, that you're mixing in? If it matters how dark or light it is? Yeah, so it will still react. If it's acidic, even if it's like a dark color, but it's acidic, then your liquid will still turn, your cabbage juice will still turn the right color. So that part doesn't matter. Like you'll see that today. Like some of these are clear, like my buttermilk isn't clear, but we'll still be able to see the right color that we need to form. Okay, so let me check my time. Oh, we are just about there. We've got 20 seconds left. So one thing that you're gonna want, and I didn't put this, and I'm realizing that now, I'm sorry, this is the first time we're doing this, so we'll get better as well. Oh, good question, Miss Jones. What about coffee? Ooh, do I have any coffee to test? I actually might have some old coffee from this morning. You guys know me, haven't changed. I might test that too. But yeah, Miss Jones, if you've got some coffee ready, you should definitely test that. You can test anything you want, especially if it's a liquid. So that was the timer. The 10 minutes on my cabbage juice went off. So I'm gonna show you 2 different ways that you can do this. You're going to want a bowl. That's what I'm saying. The one thing I forgot to tell you about, because when you strain it, you want to save that liquid, right? So like, if you've just got like a bowl and a strainer like this. Oh, Zora, you can't see me. Oh, did I go away? Am I back now?
Zora, you may have to look in the side thing and find her and make sure you pin her, but she should be on your screen.
Yeah, Zora, if you're looking at the people and you click my picture, it will pin me into the center of the screen. So that way it'll stay on me. Sorry, Zora. If anyone else is having that issue and you just didn't know how to fix it. That's how you fix it. Just go to where you can see all the people and click on my picture. Great. Okay. So I'm going to take my pot with my cabbage juice, and I'm just going to hold my strainer. Let me tilt my screen down so you guys can see what's happening. I'm just going to hold my strainer over my bowl. If you want to do this in the sink, I recommend that as well. I'm just going to pour some of it out. So that way the cabbage gets stuck in the strainer and the juice goes into the bowl. I'm actually not going to do all of mine like that. While I'm here with you guys, I'm going to put it into a beaker, actually. So I'm going to use my big beaker here. So I'm going to strain mine out, and then you guys go ahead. If you're making it, strain out some of yours as well.
Fun fact, Mrs. White is actually in Tennessee with her sister so that she didn't have to be alone in her house
With my cats.
with her cats. Her cats are also in Tennessee. And Lizzie is at my house.
Oh, yes. For those of you wondering, Lizzie is safe with Miss Jones. And Hector, I don't know, some of you know Miss Downey. Hector is at Miss Downey's house. So everyone is safe and sound. So that's what my cabbage juice looks like. It's this dark purple color. I'm going to turn on, I actually don't have any lights on in the kitchen right now. So you guys can hopefully see that a little bit better. So this is the right color. So just like that, like I said, it was going to extract out with tea. Hopefully you're finding that your cabbage juice is a similar color to that. I've still got some in my pot here. I might get some more out in a second. So like I said, I was talking about earlier, like the cabbage that was in there, it's kind of that grayish color now. It's kind of green around the edges. That's because all of that flavin, that purple pigment, was pulled out of the juice while it was sitting in the hot water, pulled out of the cabbage. Great. So now we're going to start testing. So as I said, when we I can see Miss White's name. Oh, you can't see my picture? Okay, one second, Luke. Can anyone else see my picture?
Mm-hmm.
Okay. I'm not sure what's going on with that. Maybe once again, if you try and scroll through like the people, you will be able to pin my picture. There's a little pin button that you can press, and that will pin my picture onto the middle of your screen. Sorry about that. Okay, so now we're gonna start testing. So I've got all my little different containers here. I'm just gonna put a little bit of juice in each container. And if I wanna test more things, I'll just dump one out and get a new one. So like I said, you don't need a whole lot. Like this is, I know you don't have beakers, but this is about 30 milliliters of juice, which is just a couple of tablespoons. But really, if you just want to into your containers at home, whatever you're going to use, you just want to put a little bit of liquid in each of them. That one's got a little bit more. Okay. So I'm going to start testing. So at the beginning, I told you what color it would turn if it was more acidic or more basic. You might have forgotten. Does anyone remember what color it's going to turn when it is an acidic ingredient?
Green?
Opposite. Or I guess that's not really opposite. It'll turn green when it's basic. So yes, actually, that was one of the colors. But yeah, it'll turn green when it's basic. And it will turn like a red to pink if it's acidic. So the closer to green/yellow, the more basic it's going to be. The closer to red, the more acidic it's going to be. So what should I test first here? We'll go with what we're talking about in the discussion. I'm going to test some of this buttermilk. So when we're making biscuits, buttermilk is a common ingredient in that. Whew. Our buttermilk might have expired, but we'll see what happens. We haven't been doing a lot of biscuit making here. Okay, so like I said, I'm just gonna use a small amount. I'm gonna get out not even a whole teaspoon. If you have a measuring spoon, you can grab it. If you just wanna eyeball it, I just got out a half teaspoon little measuring tool right here. And I'm gonna pour this over here so I don't spill it. So I'm gonna put in my buttermilk. And I'm gonna give it a stir. Okay, so did we see a change? Let's compare.
Yes, we did.
Yeah, what happened?
It changed to a pinkish.
Yeah, so it got lighter. It changed that pinkish color. Here's our neutral cabbage juice. Oh, and I meant to show you guys this earlier. And here's our buttermilk. So I'm going to use this just so that you guys you don't have to just trust that I'm telling you that this is neutral. In those videos, you saw me using pH paper. It's called litmus paper. It's a fun word to say. I can't get it out. There we go. So this is paper that has the ability to tell us what pH something is. And there's a little chart right here that's going to tell us. So I'm going to show you this when I dip my litmus paper into my cabbage juice. Even though it's purple, my paper is going to turn that yellow color. And when I compare it on here, let me show you. Right. So it's the same color as 7 right there. And we know from our water quality unit that if something is a pH of 7, that's a neutral pH. So our buttermilk turned lighter. Does that mean that it is acidic or basic? It turned closer to pink.
Acidic.
Yeah, so it's going to be a little bit more acidic. I'm going to dip a piece of litmus paper into our buttermilk right here so we can see just where it is on the scale. So it's still pretty purple. And let me get this in the view of the camera. And it's not that much different than our neutral 7. It's a little bit darker, though, which is going to tell me that the pH of buttermilk is closer to 6, which means it's going to be slightly more acidic. Okay, so that's buttermilk. Let's test our baking soda. So once again, I'm going to take one of my containers that has my neutral cabbage juice in it. I'm going to put a little bit of baking soda in there. Like I said, that half teaspoon. Actually, maybe not even that with the baking soda. It doesn't take as much. And I'm going to give it a stir. Okay. Now I want to make sure that you guys can see this. So what color does that look like on your guys' screens?
Blue.
Yeah, it's kind of blue. It's like over on, I'm not seeing.
It looks like black. Looks like blackberry.
Yeah, it kind of does. But I'm going to try and put a light through it and maybe you'll be able to see the color a little bit better. This is a really nice teal color right now.
Ooh.
If you've got baking soda at home and you're testing it, then you can probably see that. Is anyone else testing baking soda? Where is? I know you guys will be shocked, but I can't find where I set my phone down.
Oof.
Oh, there it is. Okay. So let me see if I put a flashlight underneath of this, maybe we'll be able to see that teal color a little bit better because it's dark. Oh yeah, so can you guys kind of see how that's teal?
Ooh, that looks like a light blue. That looks pretty. That looks like an ocean blue.
Yeah, it's like, yeah, that's a good way to describe it, Ashley. It's an ocean blue. Yeah. Oh, Ashley, did the cheese not work?
No, I haven't tried it yet, but I want to make sure that I know.
Oh, okay. Yeah. If you try the cheese later, let me know if it works, okay?
All right. Should I send you a message or like
Oh,
tell you?
Oh, yeah. You can do either.
Okay.
Okay. So if this one turned this darker bluish green, is that going to be acidic or basic?
Basic?
Yep, basic. Okay. I'm going to go lemon juice next. So I'm going to take some of this lemon juice. Oh yeah, that's 100%. Yeah, it's you can just watch. I'm so glad for those of you who aren't doing this along with me. I'm so
Yeah, it's definitely a
glad
system.
you are still here, just so that I can see you and interact with you. I miss you all so much. So I'm gonna try and put together one of these probably around once a week. So if you can't, if you don't have these things, or if you just don't feel like it, you just don't want to hang out and watch, I'm fine with that. I'm so happy that you're here anyway. So I'm going to take a little bit of lemon juice. I'm going to put it, I'm not going to use my teaspoon right now because it has baking powder in it, and I don't want to mix those two together, or baking soda. So I'm just going to put a splash in here, a couple drops. Okay, and this one, woohoo!
She still can't see you.
Look, you still can't see me. I'm not sure.
Maybe if she watches the recording, she can see you.
Yeah. Or if you exit out and if you like leave the meeting and rejoin with the link, that might fix it. But I'm not sure why yours isn't letting you see me. Okay. Whoever's watching here. What happens with our lemon juice?
Hey, Ashley, mute your mic, babe.
Thank you. What happened with our lemon juice? You can type it in, or you can, if you unmute to answer a question, that's fine. Just remember to mute again. So we have this super bright red color. So if I'm gonna put these in order of how basic or how acidic they are. I'm on basic over on this side and acidic over here. So where should this one go? My lemon juice. Oh, good. I'm glad to see that it worked, Luke. Yeah, it's gonna go, Isabella said left. I think this is what you mean. Yeah, left. So it's gonna go over here. Right now, the lemon juice is the most acidic thing that I've tested. Okay, I'm gonna take another one of my beakers that has my neutral cabbage juice in it. Let's test my LaCroix. See what happens. Put a splash in here. Drink the rest of that later. Oh! Oh, wow. Okay, so my LaCroix is actually really similar to my buttermilk as far as acidity. So it's not quite neutral, even though water typically has a pH of 7. But with this one being seltzer water, which means that it has carbon dioxide in it, and it says naturally essenced, so that means there's some ingredient to make it taste like limes. It's going to be a little bit more acidic. Ashley, are you asking what color neutral would be? Yeah, so neutral is this dark purple, this color that our cabbage juice was when it came off the stove. That's neutral right there. So even though it's that darker one. Yeah, thank you for pointing that out, Luke. I started to do that with the buttermilk, but then didn't do it with the other ones. So let me test these with the pH strips. Okay, so we did our buttermilk, found out that it was around 6. Let me test our baking soda. So when I dip my pH strip into the baking soda solution, It's harder for you guys to see on the screen, but it's a green color. Let me show you that on the strip. So baking soda is going to be closer down here. It's really hard for me to navigate holding things in front of the camera right now. Yeah, so baking soda is going to be down here closer to 9. Baking soda is actually going to be a little bit between 8 and 9. So it's going to be slightly more basic. It's not super basic, but it is definitely not neutral. I'm going to put this far away from me because remember, we don't eat or drink when we're doing a lab, and I'm going to want to drink this. So I'm going to move it to the other side of the counter so I don't pick it up and drink it. Okay. Let me test the lemon juice now so you guys can see the pH of that on our litmus paper. So our lemon juice turned a darker pink. That's not helping you see it. It turned a darker pink, and it's going to be down here. So lemon juice has about a pH of 2. That's not showing up super well on my camera, but on our little color chart here, lemon juice matches with the pH of 2. So remember, the closer it is to 0, the more acidic it is. Okay. And LaCroix is going to be right. We can just compare the colors. That's fine. Yeah, if you guys have to go early, that's perfectly fine. You guys feel free. Head out when you need to. We'll put the recording out and you can watch what you missed later. So our LaCroix is going to be about the same pH right here. We can just compare these colors as our buttermilk. So it's going to be around 6. Okay. We have 2 things left that I haven't tested that I already pulled out, the oven cleaner and the lime. So let me get a little bit more juice in this beaker. I'm going to test the oven cleaner in this. So if you are using like a chemical or something like this is where it actually is important. That's why I was joking when I was talking about not drinking the LaCroix, but if you're testing like a cleaner, you want to make sure that you clean your kitchen up really well and you're not putting your hands near your face because like you don't want to ingest something like oven cleaner. I'm wearing my safety glasses today. Everything I'm working with is safe. So it's okay if you don't have safety glasses on your own. But just modeling some lab gear for you. Okay, so I'm just gonna put a little bit of oven cleaner in my thing. If you're doing something like Windex, you could just spray a little bit of Windex in. And it's gonna foam a little bit. I'm gonna swirl that around. Woo! What color are we seeing?
Green?
Yeah. So oven cleaner is gonna be, it's really basic. Oven cleaner is really basic. Like I said, yeah, Erin, Miss Jo, I'm sorry, it is a grosser color. As it settles, it'll clear up a little bit and it won't be as gross, but this is gonna be that really basic greenish yellow color. Base ingredients are really good cleaners. So if it's a strong cleaner, that means it's gonna be really basic. I'm gonna put the lid on this again. And I'm gonna test it with that pH strip right now. So I'm gonna take a new piece of litmus paper. Yes, it is also really dangerous. That's what I'm talking about, where I'm not gonna like drink my LaCroix or anything since I'm using one of those cleaners. They're really strong, but there's a lot of harsh chemicals in them and they're really dangerous too if you are like working in your kitchen area. Like I'm gonna have to make sure I clean this up really well. Okay, so I dip my litmus paper in. Yeah, and it's, actually, I might need to let that foam settle before that works. I'm gonna come back to the oven cleaner because now it's just covered in foam. So I'm gonna test one more thing. Oh, I have that lime out. So lime, remember, is a mineral found in limestone. I'm gonna put a splash of purple juice that's left. Oh, let me tilt this down so you guys can see. This is, remember, my neutral base right here. I'm going to take a little bit of my lime. I'm going to put it in. And I'm going to swirl it up. And what color are we seeing there? Yeah, greenish. Yeah, it's like a, yeah, it's pretty green. It's a little bit opaque since lime doesn't dissolve that well. So our liquid's going to be a little bit more opaque here, the solution that we're making. But it's definitely that greenish color. So we want to go from our bluish purple in the middle to greenish yellow at the end. So this one is basic. Where should it go in this order though? Should it go over here in spot number 1, spot number 2, or spot number 3? Spot number 1, in between them for spot number 2, or spot number 3 over there? Yeah. Oh, Kata, it is sort of an emerald green. Yeah, Eva, you got it. Spot number 2. So this one is still like that ocean blue. It's a little bit teal, but it's closer to blue. This one's green, and this one is green yellow, which is telling us that it's super basic over here. Over here, we have our acids. I had one more acid that I was going to test, and I don't know where it went. But I have my lemon juice. I have my buttermilk. That's what that word is. And I have my LaCroix over here that I tested. These two are kind of the same. This one is a little bit lighter. I don't know if you guys can see that in your camera, but my LaCroix is a little bit lighter. So I'm going to put that right there. So if we're looking, let me pull everything back. We can kind of see this rainbow of colors on our cabbage pH scale. So this beaker right here is neutral, but we go from neutral 7 to like around 6, between 6 and 5, all the way down here to 2, and then working our way up from neutral 7 to a pH of 8. pH, let's test this with our paper. So I dipped that in. I'm going to compare it to my little chart. Yeah, that guy's at a pH of 10. It's hard for me to show you that. But that guy's at like a pH of 10. All the way over here to my oven cleaner, which is going to be closer to a pH of 14, which is as high as our, it's not going to be quite 14. Oven cleaner is probably going to be around 13. I'll test it with this strip here in a second. But remember, the lowest we go is 1. And the highest we go is 14. So if we were in the lab, we could test like some hydrochloric acid. Hydrochloric acid is going to be down here with a pH of 1. And then, trying to think of what would be super basic. Something like sodium hydroxide, which is a chemical that would be all the way up here at 14. So do you guys have, if you guys want to, Miss Jones was asking, what is lime used for? Oh, because I told you I was going to tell you what lime was used for. So lime, just this mineral, that powder, people often use it like in landscaping or gardening or in a lake. If something is too acidic, they'll put lime in the water to neutralize that acid, which I'm going to show you guys here in just a second. But first, does anyone doing this at home, did you test something that I didn't test? And do you want to show the class with your camera? I can put you guys on the big screen. If anyone has something that they tested that they want to show everyone what it looked like. If you have something, you can either just unmute yourself or you can put it in the chat. Anyone? Oh, Kata, awesome. Okay, so Kata, do you have your camera on? I'm going to unpin myself. Kata, if you click your picture, or can everyone see Kata now? If you click on Kata's picture, yeah, it'll put her big in the screen. Kata, what did you test?
Lemon juice,
Yeah?
white distilled vinegar,
Oh, nice.
club soda,
Uh-huh.
Windex, and baking soda.
And baking soda? Awesome. Were your colors, that of the ones that we tested, were they about the same? Their little cups? Oh, yeah, look at them. So which one is Windex?
This one.
So was Windex acidic or basic? Ooh.
I don't know.
Well, if it's going to be, what?
Basic?
Yeah, basic. Yeah. So the more blue to green to yellow it is, the more basic it's going to be. So Windex looks like it's that really pretty blue color, but it's still close to what we started with. So it's not going to be super basic. It's going to probably be somewhere between an 8 and a 9 on our pH scale. What happened with your club soda? Was there any color change? Oh yeah, there's a little bit of a change there. So even though it was flat club soda, you still saw a little bit of that change. Oh, and what was vinegar? I didn't test vinegar. Okay, yeah, so it's similar to that. Is it more red or less red than your lemon juice?
More.
It's more red. So
Yeah.
vinegar is going to be more acidic than lemon juice. If it's awesome. Good job, Kata. That looks so great. I'm glad it worked. Does anyone else have one there? I can unpin you from the screen. Eva, pull it up. If Eva, I think I'm not sure if I'm controlling this part or if someone else is. But I just pinned you to the screen. Do we all see Eva?
I got this. What I used was this.
So Eva, that was some kind of cleaner that you had? Is that what it was?
Yeah.
Very cool.
Now I'm muted. Sorry, guys. My computer died there. So I jumped back in on my phone while I'm getting my computer plugged in. Eva, did you already show everyone what you tested?
Yeah.
Oh, can I get a quick look?
Yes.
Yeah. What was that?
What I used was a cleaner.
Oh, cool. And did you find it to be a basic?
Yeah.
Yeah. Yeah, most cleaners are. Let's see if I know the password to this computer. Yes, I do. Awesome, Eva. Good job. Now we're talking about cute dogs. Everyone's dog is cute, I'm sure. Okay, I've almost got my computer back up. While I'm pulling this up, is there anyone else that wants to show what they tested? Okay, that's okay. I'm going to show you guys one more thing before we go. So in our activities, so in the prep work that we were doing, sorry, I'm multitasking, trying to bring my computer back up online. In the prep work that we were talking about neutralization reactions. So neutralization actions are neutralization reactions happen when we mix an acid and a base. They go back to that neutral pH of 7. you saw this in our prep work video when I did it with the pH strips with the baking soda solution and the vinegar solution. And then when we mixed them together, they were back to that pH of 7. So this cabbage juice is actually a really cool way to see that happen. So one second, let me, I'm not great at multitasking. Oh my gosh, so many things are asking me to do quick things. Okay. Oh my gosh. Anyone got a good joke while I get my computer set?
Ruby, do you know any jokes?
You don't have any jokes? Okay, hold on. We might have gotten it. What? Someone ask a joke? Someone tell a joke? Okay, hold on 1 second. I'm going to leave on my phone and I'm going to come back on my computer. Thank you guys for bearing with me there. I'm back. Got everything all set. So I'm going to show you a neutralization reaction really quickly. So I'm going to take something that was really acidic. I'm going to take my lemon juice. And what was something I tested that was basic? I'm going to take my baking soda. So I have something that's really acidic, and I have something that's really basic, or not really basic. Baking soda was just over 7. But what I'm going to do is just a little bit at a time. And if you've got baking soda at home and you are doing this, then you can do it too. I'm just going to put in a little bit of my baking soda, not a whole lot at first. But I'm going to do this until I start to see a color change. So remember, this is what my neutral liquid looks like. So I can actually see, even though it's happening slowly, as I add baking soda, something that's basic, to my really acidic lemon juice, the color is starting to get back to that darker purple. So it's going away from that bright red that we started with. And now it's almost the exact same as neutral 7. The color is almost the same. So remember, I'll show you what it looked like to start with. This was lemon juice on its own. That's super red. And then when I added my baking soda into my lemon juice, and I added just enough to get it back to that same purple color. So that's why it's called a neutralization reaction, because when we mix that base with that acid, it's going to bring it back closer to neutral. They're going to kind of counteract each other. So that's a really good visual representation of what's going on when I say a neutralization reaction. Do you guys have any questions? That's all that I have planned for you. And we're at just about this taking an hour, which was what I was hoping it would be around there. If you guys have any questions, then you can ask them. Oh, Miss Jones asked about coffee earlier. Ooh, what about regular milk and coffee? Let's see. I'm going to dump out one of my containers because I'm out of containers. I'm going to dump out this one that I just did. Oh, this one was neutral lemon juice too. So
Jody also has a really good question. She asked if you kept adding the baking soda, would it become basic?
Oh, great question. Yes. So if I added more, actually, so I wasn't thinking, I just dumped out my one that I did that with. But if I were to add, let's say, because I added about a half teaspoon of baking soda last time. So we're going to see that chemical reaction. It's not quite as exciting as when you do baking soda and vinegar, but we know that was a chemical reaction. You guys can see the bubbles. I can hear the fizz. That gas is being created. So I just put in a teaspoon, and I'm going to put in a little bit more. So I'm going to add another half teaspoon into this. And I'm going to give that a good swirl. And it's kind of hard for you to tell in my camera, but if you're testing this at home, actually they kind of look exactly the same in the camera. But at home, this one is now a deeper blue than my neutral cabbage juice. So this one is now more basic. So I kept adding that baking soda and it's a little bit more basic now. Let me see if I can show you that on a pH strip. Oh yeah, you definitely can see it on a pH strip. So it's green. It's at about that pH of 8 now, matching that one, where my cabbage juice has this pH of 7 still. It's not as green. It's that yellow matching up there. So yeah, great question, Jody. Yeah, if you were to keep adding it, it would definitely turn. Kata, can cabbage go down the garbage disposal? Yes, I mean, definitely check with your parents, but everything that we're using right now is safe to go down your sink. Even the oven cleaner can get washed off with water, so you can dump that out. Just be careful. But yeah, definitely check with parents before you put it down the garbage disposal, but it should be fine. Miss Jones had asked earlier, she just asked, what about regular milk? And what about coffee? So 1 second. I think. It's not a lot, but there's a little. Ooh, 1 second. Oh, perfect. Yeah, so you guys know Miss White. Here's my coffee cup from this morning, and it still has coffee in it. And I'm going to put a little bit of coffee in that. Ooh, yeah, it turned a little bit brown. That's sort of where Ashley was talking about earlier, if it has a dark color. So it still worked. I can see that color change. It's going to be more acidic. It's kind of might be hard to tell through the computer, but if you look through the light, it's got that pinkish color. It's a little bit darker though. It's that little brown color because the coffee is naturally brown. So if you're using something that has a strong color, you only want to use a little bit. So coffee is acidic. Now we know. And I've got a little bit of lemon juice left in here. Not lemon juice, cabbage juice. Let me test regular milk. Looks like a mad scientist lab in my sister's kitchen right now. Okay. So here's regular cabbage juice. Regular milk. We tested buttermilk. Buttermilk was acidic. Let's put in a splash of regular milk. So I'm actually not seeing much of a color change besides it just getting a little bit more opaque. Let me put a pH strip in and see what we find. Yeah, so the pH, when I put that in, I'm finding that regular milk is, yeah, still closer to that pH of 7. So regular milk is not as acidic as buttermilk, which is one of the reasons in that discussion question for this week, when you're looking up a biscuit recipe, it said specifically look for one with buttermilk in it. Now, you can use a recipe that doesn't have buttermilk in it, but you're going to want to have another acid in your in your ingredient. Miss Jones says, would the fat content matter? I don't know. Like in your milk, there's 2%, 0.5%, whole percent. That's how much fat is in your milk. I don't know, Miss Jones. So most fats are neutral. So like unsalted butter is neutral. Most things like that don't have a pH. But that might create a difference if there's different amounts of fat in your milk. I only have that milk, which was 2%. But if you want to do this on your own later and you've got like whole percent or 0.5% or skim milk, test it out and let me know what you guys get. Tell me if it's more acidic or basic. That's a great question. Yeah, and Luke, you did answer that question. Yeah, so I'm going to send out the information tonight for our next one. Our next one is really easy. It's going to be, all you need is lemon juice and like a heat source. So like a hair dryer would probably be best. You can also use a stove. That's going to be a little bit trickier. But all you need for our next one of these is just going to be lemon juice and heat. It's a really simple reaction that we're going to be talking about next week. But I'm going to send that out in Remind as soon as this is over. I'm going to get that typed up. So yeah, I'm going to try and do one of these every week. So that way I still get to see you guys and spend time with you. I miss you. Jody asked, does the temperature of the liquids affect anything? So in our chemical reactions, and this is going to be a little bit of preview for our PowerPoint for next week. The temperature will change the rate at which the reaction happens. So when we have an acid and a base, they're interacting, they will still interact if they're at different temperatures. It just depends on how quickly they will react. Yeah, so it won't affect like the pH. So lemon juice will still be acidic even when it's warm. Now, actually, so I'm saying this, and as I'm saying it, Jody, that's a great question, and I actually want to do more research into that. I can't fully answer that question right now. I don't want to say something that might be wrong. So in some cases, I don't think it would matter, but in other cases, if you were to like heat it up to the point of boiling, that might change the pH actually. So that's some great further research to do. If one of you guys wants to look that up and tell me, does increasing the temperature drastically change the pH? I don't know the answer to that. So great question, Jody. Anything else? Say if you guys have somewhere you got to go, you are fine. I've gone through everything I wanted to go through the experiment. Oh, no, I didn't. One more thing. So I was telling you earlier, these little litmus papers here, you can buy them at like a science supply store, but you can also make your own. So if you made this cabbage juice solution and you have coffee filters, so this is a coffee filter and like for a different type of coffee pot. But if you've got this solution and you've got coffee papers, you can dip your paper into your cabbage juice solution and then let it dry. This is one that I did 2 days ago when I was testing this out. I haven't actually tested it yet because I wanted to test it with you guys, but it should work like our pH paper. So I'm actually going to cut this right now into a strip. So I dipped this coffee filter into my cabbage juice 2 days ago. I let it sit out and dry. Let's see if this works. I want to test, I don't want to put it in one of these beakers. I'm going to put it, got one right here. So I'm just going to put a splash of lemon juice in this empty beaker. And I'm going to set my, so hopefully this works. Like I said, I haven't tested it out with you guys. I mean, without this yet. So I'm going to put that in there. And it is just kind of clear, but it's a little bit pink. That's going to be really hard for you guys to see on your end of things, but it's a little bit pink. My coffee filter is there, but it mostly turned clear. Let me try something now that I know is going to be basic, because it turned a little bit pink with my lemon juice. I'm going to take this beaker and I'm going to put in a little bit of water, and I'm going to mix in with my water some of this oven cleaner because I know that was super basic. So this is a water and oven cleaner solution, and let's see what happens. Boop. Oh yeah. And now it's once again, it's hard to see on you guys through the camera, but on my end, it is definitely that darker green color. So you're not going to see as drastic as you would with like litmus paper, but there's definitely a slight color change to these coffee filters. So if you want to make your own paper and you can test these, all you got to do, oh yeah, if I pull up a piece of white paper, maybe you'll be able to see it. So like you can see how that one is a little bit green and this one is a little bit pink. That was the lemon juice. This is the oven cleaner. So you can make your own litmus paper at home with your cabbage juice. You just got to dip a coffee filter in it and let it dry. And then you can cut it up and you can test anything you want to see its pH. Also, I miss you guys so much too. I'm so happy so many of you came to this. Hopefully you can come to our one next Wednesday too. I just loved seeing your faces and hearing your voices. It was great. Like I said, you guys reach out to us anytime. If you ever have questions with Canvas, we are here to help you. We know this is a big transition, and we want to do everything we can to make this as easy as possible for you guys. But also, if you have questions that aren't related to Canvas, or if you just want to say hi, do it. Send us an email. Send us a chat on Google Hangouts. If you guys ever want to organize like something like this with a meet, let us know. Or if you want to, I know Miss Jones, you're doing live office hours. I think I'm going to start doing that as well. So it will be something like this where we can actually talk face to face about some of our questions.
Absolutely. You've inspired me to do a live first chapter Friday for this week. So.
Oh, yay! Oh, I'm going to do that. What are we doing? Or are you doing? I'm not doing anything.
Haven't decided yet. I have a pile by my bed, so I'm going to pick one.
That's so great. I'm slowly working through it. Guys, when school was out, I went into Miss Jones's room and I took about like at least 10 books to read while we were out. I'm slowly working my way through them. But yeah, so if you guys have any other questions, I'll hang out for a little bit here. If you've got somewhere to be, I'm officially done. So you can hang out.